The SylFeed project aims at developing a new value chain from wood to food thanks to the Arbiom technology that converts wood residues into proteins for feed applications. During 4 years, the consortium of partners led by Arbiom focused on 3 main activities: the demonstration of the scale-up of Arbiom process to ensure technical validation of her process, the validation of performance of SylPro, Arbiom's protein-rich ingredient in aquaculture, and the comparison of the environmental performance of SylPro against other protein sources to confirm its sustainability value. Today, we're proud to share our key achievements with you. Within the SylFeed project, and with the support of SylFeed Consortium, Arbiom successfully scaled up its technology and is now ready for industrial deployment. Throughout the project, Arbiom has optimized the wood-to-food process at lab scale with rice processum, pilot and pre-industrial scale with BPF and BBEU. More than 50 runs, ranging from a few liters up to 10 cubic meter scale, were performed by Arbiom and its partners to produce Arbiom's protein-rich ingredient, SylPro. One by one, technologies and equipment's design have been validated for all the unit operations to produce SylPro at large scale. Rice processum offered its screening platform to optimize fermentation conditions, while BPF and BBEU assisted Arbiom to cross the valley of death of the demonstration scale. Arbiom is now considering the industrial deployment with confidence and look forward to the next step in its way to commercialization. More than 10 tons of protein ingredient have been produced, enabling the demonstration of this production from a technical standpoint and dissemination of samples for further testing by feed manufacturers. As a final part of the SylFeed project, a successful large-scale Atlantic salmon feeding study evaluating SylPro as a raw material in salmon grow-out diet has been completed with promising results. The 16-week trial was conducted by Matís, Icelandic Food and Biotech R&D, as part of the SylFeed Consortium. SylPro was included in salmon diets at levels of 10% and 20%, replacing a plant protein mix comprised of soy protein concentrate and wheat gluten while maintaining fish meal at constant levels. Results showed the replacement of the plant protein mix by SylPro had no statistical difference in performance compared to conventional protein ingredients in terms of fish growth rates of the Atlantic salmon at up to a 20% inclusion level in the diets. These results complement the smaller scale trials performed 2 years ago on salmon fingerlings, where similar results were obtained. Additional data will be available at the end of the project as we continue to analyze fish welfare from the trial, including gut microbiome and immune factors. SylPro shows good environmental performance compared to other viable protein sources to be used in fish feed. This is in particular valid for potential impacts to climate change. Other environmental impact categories, for instance connected to water and land use, are more difficult to compare as they are to a less degree reported and methods are under development. Environmental performance has been studied with the aid of life cycle assessment, LCA, where the work in SylFeed has used methods proposed for new product-oriented environmental legislation in Europe. The LCA work, therefore, both contributes to understand the life cycle of SylPro and progress knowledge on which environmental issues to report and how. SylFeed has validated process performance, product performance in aquafeed, and environmental performance of the wood-to-food alternative. SylFeed contributes to the reduction of the European protein gap by offering a nutritional and sustainable alternative to expand the food production potential and increasing food security in Europe.